Welcome to STARS Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Hi, and welcome to STARS Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise, and welcoming to the show, Ryan Reeves, Technical Director of Research and Innovation at the International Space Station National Laboratory. Ryan, thank you for joining us today.
Well, thank you for having me. Love talking about science that we're doing up there in space right now, and looking forward to our conversation.
Yes, it's a very exciting time right now. Also just heard about Artemis 2. That's kind of exciting news. So what are you currently working on to further the space industry? And tell me a little bit more about
Sure.
you.
So what I do is I work with researchers to get their research that they do on the ground up to the ISS. So it's a very unique platform, being able to access the microgravity environment, the space environment outside the ISS itself. But that comes with a lot of challenges as well, right? It's not a simple task to simply take what you're doing down here on Earth up there. So we work with a number of partners. We call them implementation partners. These are commercial companies which oftentimes own and operate hardware that's housed on the ISS, and they also help to shepherd researchers through the process and operate their experiments on the ISS. So our goal at the ISS National Lab is to make the most out of the opportunity that we have on the International Space Station, getting the most science and technology that we can with the amount of time that we have left up there. And so the amount of science that we do runs the gamut across, so many different technology areas. From this can take the form of cancer research, next generation materials like for electronics or healthcare, 3D printed tissues, satellite refueling, and really so much more. So currently we're wrapping up our inaugural accelerator program, Orbital Edge. This is a program that we have been doing in concert with venture capital firm partners that we've had. So that's CIRI, E2MC, and Stellar Ventures. And they're making funding available, but we are providing the access to the ISS to prove out their technologies. So there's 6 companies currently running through that program, and they're looking to shield satellites from radiation, improve the cooling capacity that they have because they're generating a lot of this heat, but then it's hard to reject that heat in the vacuum of space. And there's, one company that's looking to use the olfactory system, that's your sense of smell, to better understand how the disease progression of neurological diseases like Alzheimer's or Parkinson's progress.
Heard that.
And then also to potentially, use that as a drug pathway to be able to deliver the drugs to you for that. So we're very much looking forward to all of these companies, and really it all kind of brings it back home in that while we're doing this off Earth, it's all to benefit Earth, right? We're doing all of this to improve our lives here on Earth.
Some really exciting experiments. And I've heard that about Alzheimer's and sense of smell and dementia and those types of things. It's exciting. Plus the cancer research, that's all of them are so exciting that all these things can be taking place on the International Space Station. That's so cool. What has been maybe your biggest aha moment?
Sure. As I was going through college and my early career, I was never really into space all that much. Space was definitely cool, and I would have conversations with my buddies about what is dark matter and dark energy and things like that, kind of these philosophical questions. But I never really, it was detached from my daily life, right? It didn't impact what I was doing. And then when I started with the ISS National Lab, I really started to see how what they're doing, and they have been doing, in space for decades now, and aboard the ISS for almost 25 years now, really impacts life here on Earth. So some of the things that we've been able to see that are really informing things, we talked about cancer and neurological diseases like Alzheimer's or Parkinson's. one of the reasons that we can better study those and really learn about them in space in such a kind of foreign atmosphere to what we go through here on Earth is that the stress that the cells see in that microgravity and space environment causes them to respond in a way that looks very similar to aging, so that these diseases progress in a much faster rate up there than they do here. So that means that we can study how the diseases progress and how drug treatments work in a faster manner up there than we can down here for a number of different diseases. We've seen other things where we've been sponsoring a number of flights to a company called Lambda Vision, who is working to create artificial retinas up in space. They've been able to see that in the absence of gravity, that they get a much more uniform deposition of those materials and therefore a better overall product for that.
See and or have, yeah, be able to create that in space. That's
Right, to be able
amazing.
to create artificial retinas in space for people here on Earth, that's the kind of stuff that like really, is so interesting. And we've seen it.
I didn't even know that was going on. My mind is blown, and I think the average person doesn't realize that how much is really happening and what they're doing and how these experiments are the progress that we're being able to make with
Right.
it.
Yeah, it's hard to sometimes break through to the common public with so much else going on in the world right now. And rightfully so, there's a lot of important things going on. But, when you have conversations with folks about these kinds of things, it really opens some eyes. So, another example that I'll give is we worked with Merck, the drug company, for a
Mhm.
number of years. And so in the 2010s, we flew one of their drugs, Keytruda. This is a cancer treating drug. And they saw when they sent those up that they crystallized, and they published the results in 2019, that in space they had very small but uniform crystals, whereas if they did it on the ground, they kind of had a lot of heterogeneous or very different shaped crystals. And the reason that that matters is that the amount of drugs that are released at any one time is related to the surface area. You can think about that as, if you had a bunch of ice cubes, right? If you had a bunch of very small ice cubes, they will cool down your drink, pretty quickly. If you have a bunch of very large
Right.
blocks, they're not going to cool it down quite as fast. It works that in a similar manner. And so being able to control that drug delivery was really important. Well, just 2 weeks ago, Merck received FDA approval to now inject that drug Keytruda, now called Keytruda QLX, as a new drug delivery form. So now you don't necessarily have to go to the hospital and be under supervision when you're receiving the treatment. You could potentially receive an injectable form, and it improves the patient's comfort and their lives as a result. So it's just really
It's
exciting stuff
amazing.
that's happening.
It is exciting, and you have a lot of wins happening, but I'm sure along the way there are
Yeah,
challenges. So now I'd like to hear about maybe one of your biggest challenges and how you actually overcame
sure.
it. What would that
Yeah.
be, Ryan?
We talked a little bit about about how people haven't necessarily heard a lot about this. And when we first started the ISS National Lab and making the research opportunities available, we had heard of the ISS National Lab or didn't know that they could send research up there. So it was really about trying to inform the public and get out there. So we did a lot of kind of roadshow type activities where we went to different cities with the collaboration of NASA's ISS program office. We called those destination
Mhm.
stations, and we just went out on the road and tried to introduce different companies and get them excited about doing research. Um, Once we started to gain some traction, it was less about getting enough people, but then the challenges were really funding. We didn't have the funding to be able to pay for their research on the ground and fly them up. We were given this resource allocation to fly them to the International Space Station. So we had to go out and find partners. And we found a lot of partners with government agencies. So the National Science Foundation, they were really interested once we talked about all the potentials that they could do when you remove gravity, what the things that you could, underlying physics that you could see. And so we've now had 10 years of continuous solicitations with them, and they have really invested heavily in microgravity research because they've seen the potential of what you can learn as a result of that. Similar, we've had solicitations with the National Institutes of Health in tissue chips, so studying how some of these cells respond to microgravity and how that can be related to disease progression and treatment. More recent times, the real challenge has become now we have so much demand that we have to prioritize. So now it's about trying to make sure that we're distinguishing and getting the most promising technologies, because now it's a very valuable ticket. Folks know that the ISS isn't going to be up there forever, so they want to make sure that while they have that opportunity and while the US taxpayer is paying for it, to be able to provide the research opportunities up there, we're making the most of that opportunity.
So if the International Space Station is going to be up there forever, what's going to take its place? Something has to take its place,
Sure.
right? Because this kind of research has to
Well, yeah, I
continue.
mean, we certainly think so, and NASA does as well. So, they are working on a program. They've been calling it the Commercial LEO Destination, Low Earth Orbit Destination Program. They have a number of companies that are currently seeking to produce the next space stations. So that being Axiom Space, Blue Origin, Voyager Space. They've all been
Okay.
participating in this. Recently, VAST has joined them. So VAST is seeking to potentially fly their version, which is Haven 1, as soon as next year. And there are other companies that have been doing it outside of NASA, specifically outside of this program, doing things like uncrewed spacecraft. So Varda has sent up their much smaller capsules, but they've been doing drug crystallization in some of those, and they've published the results. So there's a number of
This
companies,
is
yeah,
exciting.
coming on after, and we just want to make sure that we're able to pave the road as best we can while we have this, so that all of these folks can really blossom once we get to a more commercialized version of all of this.
What one piece of advice would you like to share with our listeners today, Ryan?
One of the things when I first got here, that I had to kind of remove myself is you take for granted, gravity. Gravity's not a variable, right? It has a specific number, you can calculate it, and you write it in. When we go and now you remove that and you treat it as a variable, then a lot of things change. So, if we look at flammability, as you change the amount of acceleration that things receive, things get more or less flammable. And so NASA's been studying that for years. So a lot of the things that we've seen have come as a surprise, but being able to think outside the box sometimes now means thinking off-world, right? But not off-world for, some far off thing like going to Mars or something like that, but for the benefit of your own daily life, right? Through, cancer treating drugs, through the next iteration
Mhm.
of materials which will allow better fiber optic cables so that you and I can have this conversation with less lag and, less
Yeah.
interruptions. So that's the kind of thing is the challenge is trying to break people of, well, what does NASA need? But instead, what could you do if you had the opportunity and you could remove your biggest hurdle? That's where we try to break in with folks.
Before we wrap up, do you have a passion project that you'd like to share with everyone, past or present?
Well, I mentioned the fiber optic cables. One of the coolest things that I think I
Mhm.
saw was, NASA had done some studies in the early 2000s that showed that a particular kind of complex glass called Z-bland, this glass could potentially be much better than the silicon optical fibers that we have now. Less optical losses, meaning that the signal is stronger as you're going. You don't have to have big repeating elements to kind of amplify the signal as you go across, oceans as you're transmitting things. They saw that if you did this in a microgravity environment, you could potentially do it without crystals forming within there. And it's the crystals which kind of kill some of the signal. But they did it on a very
Mhm.
small scale, and it was a proof of principle, and it was very successful. So a couple companies have tried now, and we've sponsored a number of them to try to do this on the ISS, and they've had moderate results. last year, Flawless Photonics, they came in, and on the first time that they tried to draw these fibers in space, they were drawing kilometers of fiber, so miles of fiber. In total, I think that they did something like 3 miles of fiber in one draw, over a half a mile of fiber. And so to think that that's really, that we're now at a scale where we can produce miles of optical fiber was really something that I hadn't really considered, and that kind of blew my mind a little bit when we first got those results. So that's, you asked about a passion project. It's a little bit like asking who your favorite kid is, but there are certain things where, like, you brag on some. That's one that between us and collaboration with NASA and their programs, it's really led to some big successes.
And I love these successes.
If it's okay, there's a couple things that I'd like to promote, just real quick.
Sure.
So one is we have a funding opportunity out there now. So I talked about a collaboration with the National Science Foundation. We have an opportunity. The solicitation is out there. If you go to issnationallab.org/opportunities, you can find this. This is in transport phenomena. So we're looking at things like fluid physics, thermal or heat transport, up to like material science. So there's a number of different things. That solicitation is open. The first deadline for that is in January. And the other thing that I'd like to talk about real quick is that if you are interested in all the different things that are going on in the ISS, this just kind of wets your whistle, hopefully. We put out a digital magazine called Upwards that goes through all these different success stories. So that you can find at issnationallab.org/upward. And you can go back through years that we've been doing this and see all the really cool experiments that have been happening on the International Space Station.
Thank you so much for sharing your story and what you're doing to further the space industry, and not just for space, but really for what we need here on Earth. That's so cool. It's so great. Thank you so much, Ryan.
Thank you for the opportunity, and we really appreciate it.
Ryan Reeves, Technical Director of Research and Innovation at the International Space Station National Laboratory. Again, thanks for joining us on LaunchPod. Be sure and join us where we connect, collaborate, and accelerate. And we'd like you to join starsciences.org to receive a free 1-year membership. Just enter the promo code FRIENDS321, FRIENDS321. And if you enjoyed this episode, leave us a review and subscribe. And until next time, keep looking up.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars LaunchPod, propelling us forward, one launch at a time.